So here in 7.4, we're going to start out looking at number 51. So here we want to graph this function and then use the graph to determine the inverse of the function. So for 51 here, we see it's going to be something squared. That to me looks like I've got my quadratic formula stuff, which can look like this. In this instance, my h and my k values, since I don't see them, are just both 0. A value is -3, which means it's going to open down, and it's going to be steep or narrow, however you want to describe it. That's quite the S there. And then for my horizontal vertical shift, there is none. So if I were to super quickly ballpark a sketch for this thing, because we've already covered how to do the graphing in chapter 5, it would look something like that. So now as I look at this thing, we want to determine whether the inverse of f of x has a function. So what we're looking to do here is say, okay, if I flipped this thing, what would it look like? Okay, and we flip it along this line here. So if I were to flip this thing over that, is it going to have an inverse, yes or no? And so these ones can be a little bit tricky to do. I'm going to do the algebra out for it just so you guys can see that, and then we'll kind of like return back to the flip scenario. But basically, if this thing doesn't pass the horizontal line test as is, then the inverse is not going to pass the vertical line test. Oh, that's what it wants us to do anyways. Perfect. All right, so we're not even going to do the algebra part of it. We'll just stick with the horizontal. So as I look at this thing, I can tell if I run a horizontal line through it that it will not pass. It hits 2 points. So therefore, when I take this and flip it over, and I mean, forgive my artistry, but whatever, it clearly is exaggerated, but it's, you know, for the most part, going to look something like that. And we would see that that does not pass our vertical line test. So basically, if it fails the horizontal line test, it will not pass for its inverse, like quote unquote, because it doesn't have one. Any questions there?
When you do the inverse, you switch from horizontal line to vertical line?
It's not that we switch from horizontal line to vertical line, it's that we can test with a horizontal line, because that's what will be an inverse once we flip it.
Okay.
If that makes sense. So like if I had something that looked, let's see, let's do another one. So I have something that looks like that, okay? So with this line here, does it pass the vertical line test? Yes, it's a function, right? I can only put one line through that, touches at one point. Does it pass the horizontal line test? Yep, anywhere, well, that's not very horizontal. Anywhere I want to send through, it's only going to hit at one point, right? So therefore, this yellow thing is going to also have an inverse since it passed the horizontal line test. Does that help?
Yes, it does.
Perfect, perfect. Bowling handicap. Who was I talking about bowling scores with? I feel like it was you, Spencer. Let's see. In a bowling handicap, yeah. Spencer almost got a 300 one time. It was pretty close. Pretty impressive. That's why he's the man, the myth, the legend. In a bowling handicap, is set to adjust for the difference in player ability. You belong to a bowling league. Each bowler's handicap is determined by his or her average A. Using this formula, if the bowler's average is over 200, the handicap is 0. So Spencer's is 0. Find the inverse of the function. Then find your average if your handicap. Okay. If I were to rewrite this thing in terms of stuff that we have seen, it would look like this. So 0.9 times 2 hundo minus x. So this is just using different variables h and a to represent what we typically would call x and y, our input and our output. So I'm going to use h and a for this problem. I just want to like make you guys aware that this is the exact same thing. I'm also going to distribute that 0.9 into this. So I'm going to call this 180 and I'm going to call this negative 0.9x. So let's rewrite this equation as h equals Oops, sorry, I already messed up. So we're going to swap our x and our y values. So I'm going to say a equals 180 minus 0.9 h. So all I'm doing is I'm swapping my h and my a, and I also did a little bit of distribution there. Hopefully I didn't lose anybody. And now I just want to make sure I'm solving for the h value again. So what I'm going to do is I'm going to subtract over this 180. So I'll get, let's do blue. So I got a minus 180. The problem with a's is they look like 9s if you have terrible handwriting like me. And then as my next step, I'm going to say I'm going to divide by negative 0.9. So I divide by negative 0.9. And so now I get h by itself is equal to a over negative, oops. So that's going to be like that. And then our negative 180. So if we do 180 divided by 0.9, it's just going to end up giving us 200. And it becomes positive, right? Divide a negative by a negative, we get positive there. So now if it tells us find the inverse of a function, find your average if your handicap is 27. So now this is kind of weird that it wants us to just plug a number in, but whatever. So now we just are plugging in, let's do a different color though. So make a copy here. Part 2 of this problem says our handicap is 27, find the average, so minus 0.9 times 27. There we go. So 0.9 times 27 gives me 24.3. So we would say the bowler's average is about 155.7. Probably the lowest Spencer's ever bowled. Any questions on this one?
Is that going to be on the test?
It's fair game, but probably wouldn't show up in this format.
Okay.
But like I would have you guys, find an inverse function and also be able to plug in numbers to it.
All right.
The alternative that we could have done is plug the 27 in here, but it doesn't make much sense to do that. It's much easier just to plug it back into this formula here. But yeah, good question. Anything else on 59? Perfect. I think that was it for 7-4. Nice.